Pythagoras theorem. Okay, what Pythagoras told. Okay, that is a relative how to find the distance. Okay, distance or length in a right angle triangle. That is our Pythagoras theorem. Okay, we will consider this. Okay, this is a right angle triangle. In this, there are three sides. Okay, there are three sides. When we consider about this angle, okay, this angle, the side which is nearby this angle called as adjacent. Okay, this is our adjacent side, and the side opposite to this respective angle is classified as opposite angle. Sorry, opposite side. Okay, there are three major things in this Pythagoras theorem. Those are adjacent side and opposite side and hypotenuse. Those are the three sides classified in the Pythagoras theorem. First thing, we cannot classify any sides with adjacent side or opposite side. With respect to an angle, we can classify the sides accordingly. The side which is aligned with this angle, okay, which is near to this angle, that is called as adjacent, and the side which is opposite to that, okay, the side opposite to that respective angle is called as opposite side, and the side which is opposite to the right angle, that is our hypotenuse. Okay, this is our hypotenuse. The relationship between the sides, okay, length of sides in a right angle triangle. Okay, that is the thing called as Pythagoras theorem. What Pythagoras told? Yeah. Okay, this is our adjacent side, this is our opposite side, this is our hypotenuse. He is saying that the hypotenuse, okay, hypotenuse side square equals to adjacent side square plus opposite side square. That's the only thing what he is telling. Okay. Hypotenuse square. That means the length of hypotenuse, its square equals to adjacent side square and opposite side square. That's all for our Pythagoras theorem. Okay. If we know any of these two sides, if we know adjacent side and opposite side in a right angle triangle, we can use this Pythagoras theorem to find our hypotenuse length. If we know hypotenuse and opposite, that one also. We can substitute the according values in this formula to find our adjacent side's length. Otherwise, if we know adjacent side and hypotenuse, same thing. We can substitute adjacent side square plus hypotenuse square in this formula to find our opposite side length. Okay, opposite side length. That's all for our Pythagoras theorem. Okay, let's do an example with this theorem. Okay, if I give you a question, okay, the major condition to use the Pythagoras theorem, that should be a right angle triangle. Otherwise, we can't use the Pythagoras theorem. So here, I'll give you this side as 3 centimeters and this side as 4 centimeters. Okay, 4 centimeters. I'm asking you to find the length. Find x. Okay, find x. That is the question here. Okay, you should find the length of x. For that, we can use the Pythagoras theorem. Hence, this is a right angle triangle. We can write the Pythagoras theorem. So, what he is saying? Hypotenuse. Yeah, hypotenuse means the side which is opposite to the right angle. So, x square equals to adjacent side square. So 3 square plus opposite side square. Opposite side square means 4 square. So hypotenuse square equals to adjacent side square plus opposite side square. So x square equals to, let's expand this. 3 square means plus 9, 4 square plus 16. So it will become 25. Okay, 25. But 25 is also a square number. If you know this square relationship, we know that 24 is also a square number. So we can write x square equals to 25. 25 can be write like this. 5 square. Okay, x square equals to 5 square. Now think without this square function. Okay, without this square function. Here both particle has square function. So let's neglect this. Otherwise, we can furthermore use our calculations to find our answer. Otherwise, you can use this method to find the answer. Okay, there are two possible methods. I'll explain both methods. Here x square can be write like this, equals to 5 square. Let's neglect our square function. Both has square function, so let's neglect that. So finally, our x equals to 5. The unit should be centimeters because other units are indicated in centimeters now. So for x also, the length of hypotenuse in this right angle triangle is equals to 5 centimeters. 5 centimeters. Otherwise, another method also possible. Okay, same like this. Okay. After this step, x square equals to 25. We found x square equals to 25. Okay, to find x, we have to find the square root of 25. Square root of 25, that should be x equals to 5. Unit is centimeters. Both are similar. Okay, both are similar. If you are clear with the square functions, we can directly find our answer. 25 can be written like this. Okay, we can write like this. X square equals to 5 square. Then after, let's neglect our powers. Okay, both has 2. The power in its square form. Let's neglect that. So x equals to 5 centimeters. Otherwise, you can use this method. If you don't have any idea how to find the square roots, the square number directly, x square equals to 25 to find the x value, because we don't need the x square value. We just need x value because that is our length in this right triangle. Okay, that is our hypotenuse. So that should be equal to square root of 25. Okay, square root of 25. You have a great idea about this square root. You can ask a question from me. X is, okay, square root of 25. In this case, x can be positive 5 or x can be negative. There are two possibilities for our x values. Okay, there are two possibilities for x values, because hence x equals to square root of 25. When we find the square root of 25, we can write like this: positive 5 and negative 5. These are the two possible answers. But in this case, the thing is, x is a length. Okay, x is a particular length. Length cannot be a negative value. So, length cannot be a negative value. So, no need to consider about this negative value. X cannot be negative 5 now. Because how can we write? X equals to negative 5 centimeters. So, in here, x cannot be negative 5. So, we can consider only this answer. So, x is equals to 5 centimeters. 5 centimeters. This is the way you have to find hypotenuse length in a right triangle. Okay.